Hello students, I hope you are good, well and fine. And today we will be continuing our discussion on statistics. And in today's class, we will be seeing measures of central tendency, the mean, median, mode, and their properties, the combined mean and the properties for the median and also for the mode. Let's discuss first of all the main three terms for the central tendency, which are mean, median, mode. You will see that what do we mean by median, what do we mean by median, what do we mean by mode. So let's jump to next. Now, so a mean, the mean of a number of observation is the sum. So it is the sum of the values of all the observation divided by the total number of observation. For example, if you see, for example, I have some observation, let's say the observations are as follows: the 9, 10, 11, 12. Okay, now if I have to find the mean for these values, then I just add all the observation, the sum of all the values of the observations, and then divided it by the total number of observations. So the total number of observation I have is 1 2 3 4, just 4 values. So this is my mean, and this mean by symbol is denoted by x bar and read as x bar. Okay, so x little bar above x. Okay, so mean is just the sum of all values of all the observation divided by the total number of observations. I hope this is clear. Now let's move to next. The properties for the mean. If I have a mean for some observation, let's say my observations are x1, x2 till xn. The total number of observations are n observations. Then my mean will be the sum of all the values of observations, which is x1 plus x2 plus xn divided by n. This is my mean. And if a constant real number a is added, so this number a is added to each of the observation, so this means the new observation is will be my x1 plus a, x2 plus a, because a is added to each of my observation till xn plus a. Okay, so the number of observation remains the same, n. So the new so my new mean will be the sum of all observations. So my new observations are these. So by just adding all of these, x1 plus a, x2 plus a till xn plus a. So by n, if I remove these small brackets, then I can easily make a or this term a value add to n times, that is a appears to be added n times. So x1 plus x2 and other things will remains as it is, a added n times divided by n. So I just separate them. This will be my x1 plus x2 plus till xn by n plus n times a by n get cancelled. So this is my just a, and I already know what it is. It is my x bar, or the mean for the original observation. So this so the new mean is equals to the old mean plus a. Okay, I hope this is clear. So if a constant number is added, so a is any constant number which is added to every observation, then my new mean will be the old mean plus the constant term. So this will be my then, not a. Okay. And now if you see the second point says if a constant real number a is now subtracted. In previous we talked about addition, here we are talking about a subtraction. So by just on the same steps we can say that my new mean will be the old mean minus a. I hope this is very clear to you. The proof for this is the same as we did. We just use the minus sign over here. I hope you are getting what I am saying. So this will be this just. Okay, I hope this is clear. Let's move next. Now the C point says if a constant real number a is multiplied with each of the observation, then my new mean will be a times x bar, or a times mean of old observations. Okay, I hope this is clear. In the similar manner, if each of the observation is divided, so it is divided by a constant number a, so it will be the constant number a, then my new mean will be the old mean divided by a. I hope this is all clear to you. Let's move to next and see what is the mean for the ungrouped data. So mean for the ungrouped data is this that x1, x2, x3 ... till xn. These are my observations and number of observations are n. Then my arithmetic mean will be my x1 plus, or which I have already told you, the sum of all observations divided by the total number of observations, which is, in short form we write like this. So let me give what do we mean by this symbol. So this means first of all, this is my sigma symbol, not sigma, it is my summation symbol. Okay, summation symbol, and this is used for addition or sum. Okay, so if something is written like this, I is equals to 1 2 3, and here we write I, so this means we are adding I from 1 2 3. This means 1 plus 2 plus 3. So we are adding I. So we replace I first at 1, then 2, then 3. The lower limit for the sum is 1 and the upper limit for the sum is 2. In this similar way, this means my xi are adding till n. So this means x1 plus x2 plus till xn. I hope this is clear to you. Or for example, let's take another example. Say fi. Okay, this is my capital F, in bracket it is fi, and I is going to 1 2 3. So this will be my f1 plus f2 plus f3. 3. I hope this is clear to you. So what do we mean by this whole symbol? Okay, I hope this is clear. And by using some manipulations, I take this n to the left side, so this is then my equation, my whole expression will become like this. The n times of the mean is equals to this term, and this term is equals to x1 plus x2 till xn, and this is my sum of all observation, which is written over here, the sum of observations. Okay, I hope this is clear to you. So let's move next. Now let's see example and try to understand the concept better. So find out the mean of the factors of 10. First of all, the factors for 10 are those numbers which divide 10 completely. So 1 divides 10, 2 divides 10, 5 divides 10, and 10 itself divides 10 completely. So these are all the factors. So in this case, I have 1, 2, 5 and 10 as my factors. These my observations. The number of observations are 4, and the sum of all observations is my 1 plus 2 plus 5 plus 10, which is 18, and divided by 4, which gives me 4.5. So my my mean will be 4.5. Okay, clear? So let's move next. Now in this question, or in this example, it says if the mean of 6, 4, 7, p and 10. So if you see, the number of observations are 1, 2, 3, 4, 5. So we have 5 observations, and its mean given to us is 8. So x bar is 8. We need to find out the value for p. So by using formula, x1 plus x2 plus x3 plus x4 plus x5 divided by 5 is equals to the x bar. We know x bar is 8. We know x1 is my 6, x2 is my 4, x3 is my 7, x4 is my p, and x5 is my 10. I hope all are clear. Now just add all of the like terms or the numerical values, which this becomes 10, this becomes 17, and with this it becomes 27. So just do some manipulations. It is now 5, which is 40, and p is equals to 40 minus 27, which is 13. So the value for p is 13. I hope this is clear. So this was my x bar, and these were my observations, and number of observations was 5. So value for p is equals to 13. I hope this is clear. Now method for mean of ungrouped frequency distribution. So let's see, if we are given ungrouped frequency distribution. In previous, we are given a set of data, and we have to find out the mean for those discrete values. In here, if frequency distribution is given, so the mean for that ungrouped frequency distribution is defined as the sum of f I xi divided by sum of fi. You will see what do I mean by this. So for example, my table is given like this: xi values and fi values, and the product we can easily find out. So let's see. Let's understand by our example. Just remember the formula here to find out the mean in this case. So let's see our first example. So here my class interval is given. Okay, now the number of students is my fi. So fi is also given. Fi means frequency. So 6, 8, 13 and 7. Now this will be my xi's, or the class mark or my mid values. So my mid values is just nothing. It is the upper limit of the class minus lower limit, the plus lower limit of the class divided by 2, which is 15. Same with this, 50 divided by 2 is 25, 70 divided by 2 is 35, and 90 divided by 2 is 45. I hope this is clear. What are my FIs? FIs means frequency, and XIs means the class mark or the mid values of the class interval. Now just multiply them to get my FI XI. It is FI XI. So multiply them. 6 times 15 is 90, 8 times 25 is 200, 13 times 35 is 455, 7 times 45 is 315. I hope this is very clear to you. Now for the class interval 50 to 60, the number of frequencies as given follows. For 50 to 60 is 3, 60 to 70 is 2, 70 to 80 is 1, and their respective mid values or the value for xi or the class marks are 55, 65, 75. Now just add all of the fi. Sum fi means f1 plus f2 plus f3. So whatever the last number we sum till that, so f last term. Okay, so that's it. So in here the last term is this. So 3 plus 2 plus 1 is 6 in previous terms. Okay, 6 plus 6 is 18, 18 plus 8 is 26, and 26 plus 13 is 30. Let me add them again. So 6 plus 8 is 14, 14 plus 13 is 27, and 27 plus 7 is 34, and 34 plus 3 is 37, 37 plus 2 is 39, 39 plus 1 is 40. I hope now this is clear. Okay, now in the similar manner we will find out the sum of fxi, the sum fixi, which will be f1 x1 plus f2 x2 plus till the my f last term x last term. So this is my last term, so I'll add all of the above terms. So the final answer is written over here, 1430. And to find out the mean, we have our formula, the sum of fi xi divided by sum of fi, which is 1430 divided by 40, which will be 35.5. So this is my mean. I hope this is clear. So we use just nothing but the formula. So the main or the important element is this formula to find out the mean of ungrouped data. Okay, so let's move next. Now we'll see combined mean. What do we mean by combined mean? So if let's say if I have given two series or two or more series having different AMs and number of items. Now both of those series are now combining together. Then my combined mean of all the series is now calculated as, in case of two series, for example, my first series is this one. The series first series with observations equal to S1, S2, S3, okay, and so on. And for second series with observations say L1, L2, L3 and so on till Sn here and Lm here. So the number of observations are m here and the number of observations are n here. Okay, now this first series having some arithmetic mean say x bar, and this first means the mean for the first series, and for this series we are having the mean say x bar 2. Okay, I hope this is clear. Now if we have to find out the combined mean, that means we are combining the both of the series. So now my new series, my combined series will look like the S1 till Sn, L1 till Lm. So my total number of observations are n plus m. So n plus m, and my new the new combined mean. So new combined mean is equals to my previous combined mean. Let's say, so my new combined mean is equals to, so by using the definition S1 we just add all of the observation S1 S2 till Sn plus L1 till Lm and divided by n plus m, the total number of observations. Now I can, from this we know x1 bar is equals to S1 plus Sn by n, which means n times x1 bar is equals to sum of all observations for the first series, which is Sn. And in the similar manner for this x2 bar, m times x2 bar is equals to L1 plus till Lm. I hope this is clear. I just replace the S1 plus S2. I'm going to replace this value S1 plus S2 plus till Sn by this term. Now n x1 bar, and I am replacing this term by m times of x2 bar plus m times of x2 bar, and this is already there, so n plus m. So for two series this will be my combined mean. Or okay, so this is whole the derivation for this formula, or you just remember the formula over here. So n1 is the total number of observation for the first series, n2 is the total number of observation for the second series, and x1 bar is the mean for the first series, and x2 bar is the mean for the second series. I hope this is clear. Now what if more than two series are given? Then we just do nothing. We multiply the respective mean and the respective number of observation for the series. For example, given here, which is it is the number of observation in series 1, it is the mean of observations in the series 1, it is the number of observation in series 2, it is the mean of the observations in series 3, and so on till whatever times the series given. So we just now in denominator we add the total number of observation n1, n2, n3 until whatever the number of series we have to combine. I hope this is clear. So now let's move next. Okay, so here the uses of arithmetic mean is this. It is used for to calculate average marks. Okay, and it is used by businessmen to find out profit per unit. It is very important in businessmen that you know what is your profit per unit article, output per machine, average monthly income, average monthly expenditure, etc. So from the perspective of business, this plays a vital role. Okay, so let's move next. uh, Here we will be seeing now a median. We talked about a mean a lot, and here a median is just a distribution of the values of the variable which divides the distribution into two equal parts. Okay, so how we are going to now find out the median is the median of ungrouped data is quite easy. First of all, just present or the represent your data in ascending order, then count the number of observations. Let's say we are having n observations. Now if n is odd number, then my median is equals to n plus 1 by 2. For example, my observations are 1 2 3, so here the number of observation is 3. Okay, number of observations is equals to 3, which is my odd number. Then my median will be n plus 1 by 2 term. That means n is here my 3 plus 1 by 2, which is 4 by 2, which is 2. So second term is my median. So here the first term and the second term, so this term is my median. I hope this is clear. Now if n if n is even, so in this case, let's say I have observations 2 3 4 5. So here n is even 1 2 3 4. So number of observations is equals to n is equals to 4. Okay, now in this case median is equals to, so median is equals to mean of n by 2th term and n by 2th plus 1th term. That means 4 by 2. So we are talking about mean. So mean of two terms, that is n by 2th plus n by 2 plus 1th term. Okay, divided by 2. So mean means this. So here n by 2th term, which is 4 by 2, which is second term, plus the third term divided by 2, which is my, the second term is this 3, fourth term is the third term is this 4 divided by 2, which is 7 by 2, which is equals to 3.5. I hope median now is clear to you. Okay, so here let's see more examples. So first, in previous the data set is already in the increasing order. So 2 3 4 5, here 1 2 3. Okay, so let's move to the main example. So first of all, just arrange the data in ascending order. So the ascending order will be 31. What will be my next? So 25 is already there. So the 25 will placed over left to 31. Now 32. Now 37, 39, 42, 43, 45, and 46. So this is my increasing order, and then I just now what I will do, now I have reached to the first step. Now just count the total number of terms or the observations. So 1 2 3 4 5 6 7 8 9. So total is 9 and it is odd, so just add 1 to it and divide it by 2. So this will be my 5. So fifth term, fifth term will be my median. So 1 2 3 4 and 5. So this will be my median. So 39 is or will be my observation. So I hope this is clear to you. Let's move next. Now in this example, if you see, the data is already ordered in increasing order. So and now if you see, the number of observations are 1 2 3 4 5 6 7 8 9 10. So number of observations are 10, which is my even. So to find out the median, we have the formula. So median is equals to, in the case of even, it is n by 2, which is 10 by 2th term, plus 10 by 2 plus 1th term divided by 2, which is equals to fifth term, which my fifth term is this x plus 2. So x plus 2 plus, and the if you solve this, this will be sixth. So sixth term is my this, sixth term is this, divided by 2, and my median is already given to me, is equals to 24. So median is equals to already 24. If you read the example carefully, the median of the observations, these are my observation arranged in ascending order, is 24. So the median is 24. Now just solve for x. It is quite easy. So solving for x is x 2x plus 6 divided by 2 is equals to 24, and x plus 3 is equals to 24, x is equals to 21. I hope this is clear. So the value of x is 21. Okay, so the value for x is 21. I hope this cleared your understanding of mean concept and the median concept. In next class we will be discussing the remaining topics over here. So thank you for now. Thank you.